Hi guys, welcome back to the channel, and today we're going to be starting with the first chapter. It's a computer system, and it's going to be the entire chapter for CBSE class 11. So let's start with the first thing.
So now this chapter is a very theoretical chapter, so we would recommend you all to stay in touch with the chapter throughout the year, because at the end, doing so much theory in a really logical subject could get very hassling for you. So we would recommend keep in touch with this chapter all year long. So what is a computer system? Like it says over here, a computer system is a computer along with additional hardware and software together. So now hardware and software, I'm sure all of you are very familiar with these terms. Hardware is the physical components which you can actually feel and touch, and the software is what you see on your screen and cannot be physically touched by the user. So now a computer has three main components: the CPU, input devices, and output devices. Now we're going to discuss each of them in detail.
Okay, so the central processing unit, or the CPU, it's basically the processor of the computer, so it performs most of the important functions that the computer does. So it can be placed on one or more microchips, and it's given instruction through a program. So when we write a program, it instructs the CPU to perform certain tasks as per the user's requirement. So the CPU fetches data to the memory and performs arithmetic and logic operations, and then stores back to the memory. So the program instructs it how to gather data from the memory, and then there are certain components we'll discuss in a few minutes in the CPU which perform arithmetic and logic operators on this data. And then once it's done with the data, it gives it back to the memory to store. Okay, the next component is registers. So registers are a part of the CPU, and they're limited in size and number, and basically they're used to store data, instructions, or intermediate results. So the small intermediate results during calculations, it stores, like when we do addition and let's say the number is more than 9, so we carry the 1 or 2 or whatever to the next part. So similar to that. Then after that, it's the ALU, or the arithmetic logic unit. So it performs all the arithmetic and logic operations that need to be done as per the instructions of the program. So it'll do all the math, all the logical. We'll be covering that in the programming section, what all logic we use. So that's what the CPU does. It controls the computer basically as per the program that's given to it. Then we come on to the CU, or the control unit. It controls sequential instruction execution. It interprets instructions and guides data flow through the memory. The control unit basically it controls how the program's statements are executed. So basically the sequence they're in, it executes those in that sequence, and it also helps the movement of data through the memory, from the memory to the computer. And then lastly, the CPU is also known as a microprocessor because it does a lot of processing and it's very small.
So now let's talk about what input devices are. So now when you type something onto the computer, let's say on a Word document, or maybe you're texting someone, now the device, like your keyboard in this case, is taking an input. So these are devices through which the control signals are sent to the computer, right? So now these are physical devices which the user can actually see. And to convert the input data to a digital form accepted by the computer, the input devices actually are there for us. And data is temporarily stored into the RAM. So RAM is random access memory. We'll come to that shortly. And for permanent storage and future usage, it is stored in the secondary memory. So we'll discuss memory shortly. We're just giving you a brief idea of what input devices actually do for us and where all it's stored. So like you all could guess, input devices examples are keyboard, mouse, touchscreen, etc.
Okay, so the output devices. So it's pretty simple. They're devices from which we receive physical data from a computer system. So whatever we can touch and feel, any tangible things produced by the computer is basically output. So a printer gives output, right? It's an output device. It gives us printed sheets. The computer monitor you're watching this video on, it's giving you output in form of light. So output devices basically are devices through which the computer gives out output, which we can see and touch.
Okay, now Now we're going to talk about this diagram. Now you will actually find this diagram on the first page of the NCERT. Now we're going to discuss this in detail because this is a logical diagram of the computer. So I'm just going to draw it here to explain you guys. Right. So now what happens is there are two storage devices, primary memory and the secondary memory. The primary memory is located inside the CPU and the secondary memory is not located inside the CPU. Why? Because the CPU takes direct instructions from the input devices and gives an output. As you guys can see in this logical diagram here, it takes in direct input and gives an output. And there are three components to it: primary memory, control unit, and we talked about these before. So now these arrows will actually depict the flow of control between the data. So say we input something. First we'll go to the primary memory, then to the control unit, then to the arithmetic logical unit. Why so? Because the control unit will actually give the sequential instructions of how to perform the operation, and the arithmetic logical unit will go ahead and perform it. Like say if our computer wants to perform 2 multiplied by 3 plus 4. So now the arithmetic logical unit can actually just perform these operations individually. But the control unit will tell it to first solve the brackets, 2 into 7, and then the arithmetic logical unit will get a second expression which it will perform and give the final output. Okay, so this is overall how a pictorial representation of how the computer actually works. Okay, moving on.
Okay, so now we're going to talk about the computer memory. So we're going to cover the units of data storage first, the common terms you've heard, gigabyte, megabyte, kilobyte, all that stuff. And then we're going to go on to types of memory. So we have different types of memory. Is the primary memory, which is further divided into the RAM and ROM. And there's the cache memory, and finally the secondary memory. So let's start.
So now units of data storage. So now, as all of you might be aware, that the computers have millions of chips inside them called transistors. And the transistors on and off states are represented by 0 and 1. So a bit is either a 0 or a 1, basically an on state or an off state of a transistor. This is the smallest unit of a computer's memory. Now there are more units that were created in order to store things, like 4 bits gives a nibble, 8 bits gives a byte. Then now when you actually look at tables, you'll actually find 1024 bytes gives a kilobyte. But this was made on the basis that it's 2 to the power 10 because there are two transistors. I mean, there are two ways a transistor can be arranged, right? So now 1 kilobyte is 2 to the power 10 bytes, that's 1 KB. Then 1 megabyte is 2 to the power 10 kilobytes, or if you like do the math, you get 2 to the power 20 bytes. Then gigabytes, you can like do the same thing. You can convert it to bytes. You can convert between these values as much as you want, and like usually you aren't supposed to simplify so much. Like if you get 2 to the power 30 or 40, you aren't supposed to actually go ahead and simplify. You can leave it like that, and that should be good. And these are like the ways you can convert between one another, and bytes and megabytes, you bytes are 2 to the power 10. Like each subsequent is 2 to the power 10, and bytes is the first one that starts that. So yeah.
Another primary memory. So the primary memory loads program and data before processing. And basically before we process data, the primary memory will load that data so that the CPU can easily access it. And then now we have two types of primary memory. So the first is random access memory, or RAM. So you know, a lot of computers, the specifications, you'll have 4 GB RAM, 8 GB RAM, 16, 32, depending on your requirements. So that's what the RAM is. It's basically a volatile memory, which means that it retains data as long as the power is supplied to it, and it's temporary. So whenever you lose power and the computer has no power, then all the data in the primary memory is erased, right? Like when you reboot your computer, it's always erased. And it's faster than secondary memory or storage devices because it's directly to the computer. You can access it quite fast, and therefore it's much faster than the secondary memory. Second, we have read-only memory, which is ROM. So it's non-volatile, which means that even if even if the power is cut for the computer, it'll still store the data that's inside it. And it's a small, fast, permanent storage, and its contents are rarely changed. So when you start up your computer, you have the BIOS, which is the basic input operating system. So what it does is basically the basic setup of your computer once it starts, and that's stored in the ROM so that it can be accessed quite fast and it's permanent.
Okay. So now, the next slide. Now we're going to talk about cache memory. So now we know that RAM is slower than the CPU. Cache is a high-speed memory placed between. So this is placed between the CPU and the RAM. So it stores copies of the data from frequently accessed locations and reduces time to retrieve data. So like if you have a folder in your computer which you open very frequently, like maybe it's your homework project or whatever, then the more often you open it, the more like it'll open faster because it reduces time to retrieve data. That is done by the cache. And this is also used in many online platforms like frequently visited websites. They use this in servers. That's a different story. And when CPU needs some data, it first examines the cache. And if it's not there, it accesses the primary one. So this is how the RAM and the CPU actually interacts with the cache.
Yeah, there's that increases the efficiency of the computer, which can otherwise be slowed down if you have to access the primary memory every time.
That can take a lot of time.
The secondary memory, this is permanent memory. It has large storage capacity. It's slower and cheaper than main memory. So we have a lot of types of secondary memory. We have a hard disk drive, CDs, solid state drives, a lot of stuff. So you've seen in the computer specifications again, you get 512 gigabytes, 1 terabyte, a lot of different varieties. And you always notice that the secondary memory component is much larger than the primary, i.e. the RAM. That's because it's cheaper and also it's able to store a large storage capacity, as you can see here. So on the image here, we have what a hard disk drive looks like. That's what is running in a lot of your computers. It's either a hard disk drive or a solid state drive. We're not going to go into that difference, but a solid state drive is a relatively new technology, which is a sort of a flash storage. So it basically acts sort of like a USB, but larger.
So like we discussed, all of these are meant for storing things, and just like these, one more example is a pen drive where you can just store files inside a physical thing without actually having to plug it in any computer. So yeah. Now we're going to talk about how data is actually transferred between the memories and the CPU, right? So now there are buses. Buses are nothing but physical wires that are placed inside the computer, and they basically put they're placed between any two components of a computer to transfer data. Now, a computer system traditionally has three kinds of buses: data buses, address buses, and control buses. So now the data bus, like the name suggests, it transfers data between components, right? So now the data bus can go to the CPU and transfer data, and like the system bus basically comprises of all three buses. So the data bus just transfers data, and the one thing to note here is it's bidirectional. That means data can come from the CPU into the system, or it can go from the system to the CPU. And this is the only bidirectional bus in the system. Then the address bus, on the other hand, transfers the address of the data between the CPU and the main memory. So the data has to go somewhere. That is called the address. So the address of the data is transferred between CPU and memory through this. And remember, this is unidirectional. Last, we have a control bus, which communicates control signals between components again. So this is also about the controlling of how the CPU will work, etc. And as we said before, data bus is the only bidirectional bus. This is again unidirectional. So yeah.
Okay, so let's look at the microprocessor. We looked at it before in the CPU component. And so the definition is it's a small sized electronic component which carries out various tasks. Ignore the spelling error here. So it's built over an IC. So an IC is an integrated circuit, which is basically the combination of many circuit elements built onto a chip. Now, when we talk about specifications of a microprocessor, there's something we have to look at. So the first thing is word size. So word size is the maximum number of bits that a microprocessor can process. So you have 64-bit, 32-bit systems, like your computer. For example, Windows has 32-bit, 64-bit systems, and based on that, you download apps and all that stuff. So you have to be careful while looking at this because sometimes it can mess up your system. Next, we have memory size. So that's the amount of RAM that the microprocessor has. So as we discussed earlier, you have 8 GB, 4 GB, 16, etc. And then we have clock speed. So clock speed is the number of pulses per second generated by the clock inside the computer. So basically the speed at which the computer runs. And now we have the clock speeds in gigahertz. Before it was much, much slower. But now you've got speeds of, for example, my computer runs at a base speed of 2.7 gigahertz. So that's the clock speed. How many pulses per second are generated by the clock inside the computer. And then we have cores. So it's basically the computation unit. And you see 2 core systems, 4 core systems, 8 core systems, etc. And cores are many cores allow you to do more than one task. Since they do a lot of processing and computation, having more cores allows you to do more tasks. That's the simple thing.
And like if your computer has 2 cores, we call it dual core, or a quad core if it has 4, or octa core if it has 8 cores. So that's just one thing you can take care of in case you ever see it. Now we talk about what a microcontroller is. Now, like we said, a microprocessor is nothing but a CPU. But a microcontroller, on the other hand, has a fixed amount of RAM, ROM, and other peripherals, right? Which are embedded on a single chip. So now, since technology has grown faster and faster, we can see that we can put all of these components in smaller areas. So it is unlike the CPU, which only has a microprocessor. So now an example of this would be your mouse, which runs independently of your system. I mean, it has to be connected to your system, but it has its own microcontroller. And the washing machine, which has another microcontroller which helps it perform tasks once you press buttons and stuff. And it is embedded on another device to perform a particular function, and it automates simple tasks. Right? Again, washing machine, it can help you like just wash your clothes up without having to actually put much physical effort. You have to press a button, and the microcontroller does it.
Yeah, so these are designed to perform specific tasks only. Like our normal computers, the laptops we use, they can perform a variety of functions, but these microcontrollers have a specific function which allows them to have a small amount of RAM, ROM, and peripherals. That's why they can be embedded easily into different devices like ACs, cars, washing machines, etc.
Yeah.
Okay, data information. So now let's go to the next section of this chapter. It's data information. This is quite a logical chapter. Just a few rules you have to follow, which we should explain. So a computer considers everything as data. Whatever you use in a computer, it's basically data. It accesses stuff through data. Even your picture files, video files, everything is data. At the end of the day, if you look down into the files, it's all data, a lot of data, but it's a data. Then there's raw and unorganized facts, which can be processed for meaningful information. So now we're going to cover the different types of data which can be processed. The first type is structured, and it follows a strict structure. It's easy to comprehend, and it's organized into rows and columns. So basically, when you organize data, which is in a readable form to anyone, it's called structured data. As you can see in this table below, you'll also find this in your NCRT, but we have a list, this is an attendance list of different students in some class. And you're given the roll numbers, names, months, attendance. So it's very easy to read, and you can easily comprehend what this table contains. Now let's look at the other types of data.
Now we have unstructured data. Now, just like we saw in structured data, it was all in a very predefined manner, like in tables which had titles and everything. But in unstructured data, it is all there in front of us. It's not organized in any predefined or recorded format. Like you can see over here, this is like an attendance for the record of month of July for this one person. Now this is giving graphs, it's giving signatures, it's giving how many absence, and like everything. And this is not in an organized table the way you would expect it to be in structured data. Instead, there are images here, there is everything to like, and yet this is why it's called unstructured, because there's no format behind it. Now, semi-structured is a mix of both of them. There is a format, but it's somehow not structured as well, because like you can see, this is the best example to understand it, because it has internal markings to separate the data elements. Like now each time there's a name, it says name colon name and then whatever, month colon, class colon. Now this is called semi-structured because it's not exactly a structured manner where you can just read the title and know what it is, but it's not unstructured either because there is a format in some sense.
Yeah. There's a basic classification, but it's not very well organized, so it's not very easy to read. Okay, so data capturing, storage, and retrieval. So when we talk about data, a lot of different things we can do with data. So we can store data, we can capture data from different sources, we can retrieve data from places. And supposing we delete some piece of data, there are ways we can actually recover it. So let's just get into that. The first thing is data capturing. So this is basically gathering data from different sources in the digital form. Like a barcode reader, you can see the picture right here on the right. So what do these devices do? like you have the barcode reader, you can scan barcodes. You have on your phone, you probably have QR code app, so you can scan QR codes and it gives you a link for some website or something. Besides that, we have biometric scanners, which a lot of institutions use to identify their employees and members. So you enter your thumbprint and it converts that into a digital form, which can be used by computer. So that's what data capturing essentially is. After that, we have data storage. And this is the process of storing captured data for future use. So when you capture data, what are you going to do with it? You have to store it. You can't just leave it somewhere, right? Because it has to be stored so you can use it in the future. So let's say I want to input a barcode for a price for some item in the shop, right? So I scan it, and then the computer takes in that value and it'll store it in my receipt, right? So that when I get the receipt, I can see how much it cost and what my total will be. And then one more thing we talk about in data storage is a server. So we've heard servers a lot these days, with a lot of people talking about them. So servers are basically computers with larger and faster storage. So basically they're like a library for data, a huge library. You can think of that like a library stores a lot of books. A server stores a lot of data. Like if your computer stores about a terabyte of data, servers store hundreds of thousands of times more data than that. And you can see the huge rooms for servers and all that stuff. And then we have data retrieval. So that means fetching data from storage devices for using it as per the user's requirement. So let's say I want to access some data on my computer. So I'll retrieve the data, right? So I'll look for my file and then click on it, and then that's called the retrieval of my data. And then it'll minimize access time. Minimizing access time is crucial for faster processing. So the time it takes for me to access that file has to be minimized so that it's easier for the computer, right? If I click on the file and it takes 10 seconds, 20 seconds, that's not helpful for me. And if the computer is able to access it faster, it helps me as well, right? So that's what a crucial part is of data retrieval. Then we have data deletion and recovery. So sometimes a storage can malfunction or crash. You can have a virus, you can have some internal errors, some bugs, and users can also accidentally erase data. Hackers can delete data. Someone gains control of your computer and they can delete a lot of data without you knowing. Now the thing is, when data is deleted, its address is marked free and it's not completely removed, right? So when you store data, it stores it to an address, right? And when you delete that data, when you press delete, it'll actually delete the address to which the data was there. It doesn't delete the data from the memory. Unless you actually permanently delete it, meaning you erase it from the drive, the hard drive or whatever you have on your computer. And recovery is possible if the contents of memory have not been overwritten at all. So as long as that place where you store the data is not been overwritten by some other piece of data, you can actually recover the data even if the address is not there.
Yeah. So if you want to actually permanently delete something of yours which you don't want, you should overwrite it with some other file in order for safety, to make sure it can't be retrieved. Now we come on software. So now, as we talked about, the computer system has two components, hardware and software. So the software is something which we cannot touch or physically see because it is what we see on our screen. And now the software comprises of instructions and data that need to be processed by the computer hardware, right? So in other words, we can actually say it makes the hardware useful, right? So now MS Word, it is a very commonly used software with a lot of people, and they use it to write essays, they use it to write everything, and it's a software. And the software helps us, and now it's in a way making the hardware useful because now we're able to type and it's showing on the screen as a software. So now it also creates a link between the user and the hardware. And since the user needs to interact with the software, which the user cannot physically see, they have to use hardware for that. And software is a link between that. Now, there are different types of softwares that are present in a computer system. First is the operating system. I'm sure most of you know what an operating system is. It's basically one basic system software with other software just can't work. And it manages other application programs and provides security access to the system, etc. And some examples of this would be like iOS, Android, Linux, Windows, all of these. And other softwares cannot work without it. Now, system utilities are used for maintenance and configuration, like disk fragmentation tool, which is there in Windows, stuff like that. And they're meant for maintenance of the system, like it says. Device drivers are those kind of softwares which ensure proper working of the devices. It controls the functioning of a particular device, and it acts as an interface between the device and the operating system. So all of these are very crucial things which all of these different types of softwares perform. These are just the categories. There are many different types of software.
Okay, so let's move on to programming tools. So this year we'll be starting programming if you haven't done it before. Let's just talk about quickly what kind of tools we have as a programmer. So first is type of languages. So when you're coding, usually use a high-level language such as Python, Java, etc. But what it actually does is, which we'll get into in a few minutes, it's converting the code you've written into a machine-readable format. So we're going to start with low-level languages, which is basically machine language. So this language is machine-dependent, and it's based on ones and zeros and assembly language. We're going to talk about in the next chapter binary. It's a number system. We'll be talking about how to use it, how to perform operations in that. And then we have Boolean algebra after that, in which we'll be talking a lot about different logic gates and how actually these programming softwares work, the basics. So assembly language is computer specific. So if I have one computer, let's say Dell, then its assembly language not the same as a computer made by Apple, right? Because their hardware is different. So they have different assembly language based on their requirements. Then we have high-level languages. So these are instructions written using English-like sentences. So if you look at Python, it's a very readable language. And even if you haven't done coding before or programming, you should be able to understand the gist of what a program is, right? Because you have a lot of words like for, if, in, is, etc., which you can use. And these instructions are machine independent. So you do not need a machine to actually use this since you type it yourself. It's much simpler, and there's a set of rules. So there's a syntax, as it's called, which you must follow for your program to run smoothly. So this is similar to natural languages, right? As we just discussed, it uses a lot of English keywords, as a lot of the main languages. And an example, this is Java. So then we have the other type of tools are language translators, right? So a translator is an assembly high-level language to machine language. That's what it does. It converts an assembly language or a high-level language to machine language. Like a normal translator, right? One can convert from French to English, English to Japanese, etc. That's what a translator does. It converts between different programming languages. After that, it's assembler. The assembler, it converts assembly language to machine language, right? So assembly language is basically what the computer uses, and machine language is what the computer runs on, right? So assembly language is what your hardware uses, and the machine language is basically even more broken down form of that, which all the calculations take place on. Then we have the compiler. I think we missed an E here, sorry. So the compiler converts source code into machine code, right? It executes if all the rules of the language are followed. So only if the syntax is followed will the compiler actually run. And this executes the code all at once, and is found in languages like C++, for example. Whereas there's another type of translator called an interpreter using Python. So it translates line by line. So the difference between a compiler and interpreter is the compiler executes all the lines of code at once, while the interpreter executes the code line by line. That's the key difference. Next, we have programming development tools. So you have a text editor, like your Notepad, etc. It can't do anything besides you can type in it, type whatever you want. And then you have the integrated development environment, IDE. So it's a text editor plus building tools plus debugger. So when you're programming, you don't want to use a place where you can just type in stuff. You want to use an IDE because it'll also give you valuable feedback, such as where your errors are. It'll also help you compile your program, run it, and that's very valuable while programming.
And you want to see your output when you write it, so an IDE will help you run it, like right there. Right. So now we're going to talk about the types of software. So now there are two main types: application software and proprietary. Actually, there are more than two types. These are the first two types: application software and proprietary and free and open source software. So what application software are? They are for specific requirements. So now again, these can be classified in two points: general purpose and customized. So general purpose softwares are made for a general audience, like LibreOffice, browsers, like Google Chrome is a general purpose software because anyone can download it and it's meant for anyone to use as a browser. But customized softwares are meant for specific requirements. Like if a company asks you to make a website for them, it is called a customized software because that is customized for their very requirements. Now we're going to talk about proprietary or free and open source software. Now free and open source software, we write FOSS. If you find that anyway, you should understand this is what they're talking about. So an example of this is Ubuntu. So what is freeware? It's a free software without source code. Okay? So and proprietary software are paid software, like Windows. If you want, like when you buy a new laptop, you obviously want Windows inside it. So that's called a proprietary software, the one you paid for. And freeware is like a free software that you can download, but it would not give you the source code.
Okay, now we have the operating system. So what is the operating system essentially? It manages all the resources of the computer. It controls application software and device drivers, and it manages system security. So these are the three key features, key functions of the operating system. Let me just highlight that. So the objectives of the operating system are to provide services for building and running applications and provide the user with an interface with the computer. So what does the operating system do? It basically helps the user use the computer, the software inside the computer and the hardware. Otherwise, what is it? Just a machine, some machine which you can't do anything with if we don't have operating system in it. So now we'll talk about interface. So there are various interfaces through which we can use in our operating system. So you have command-based, graphical user interface, touch-based, voice-based, and gesture-based. So command-based requires user to enter specific commands. So a lot of commands, like for example, in Unix and MS-DOS, you have to enter some commands to actually run some programs and a lot of stuff, which is a bit tedious, but that's how it used to run back in the time. Graphical user interface is basically icons, menu, visual options. So it's a much simpler way. So you can just click on an icon and it'll open up what you want, right? And you have input devices like keyboards and mouses. So Windows is an example of that. Windows, then Mac OS. Next, we have touch-based interface. So all the smartphones, tablets, anything with a touchscreen using touch-based interface. Like Android, iOS, they work on touch-based interfaces. After that, we have voice-based interface, which is helpful to disabled users, because some people they're born with a disability, which prevents them from actually using some gestures or something, or they cannot see. So voice-based interface helps them a lot, like Cortana and Siri, because you can just speak to them.
It's really
this, yeah, it helps them a lot. So then gesture-based interface, some devices allow users to interact with gestures like waving and tilting. So in a lot of places, like one example might be your Xbox Kinect. You can do a lot of gestures, even in the Wii, all these gaming softwares. You can do a lot of stuff with that, a lot of gestures. And then even your tablets, you have accelerometers, which allow you to rotate devices and all. That's pretty cool stuff.
And all of these developments took over one after the other. Okay?
Yeah, it's taken a long time.
They realized the needs of the people.
Yeah.
Right. So now the last thing we're going to have in our chapter is what are the actual functions of an operating system. So like you would probably expect, it manages all the processes, manages the memory, manages the files, and manages the device. So it's basically, its job is to manage everything. So process management, what is it about? Basically, processes are tasks in action. So the operating system manages all of the simultaneous processes together, and it allocates resource usage and exchange of information among processes, right? And these are processes because they happen all the time simultaneously. Like if you have your computer open, you might have Chrome open on one side, you might have Word open on the other side. Now all of these have to be managed together. The operating system is designed in a manner that it can actually go ahead and do it for that. Memory management is like now, since these processes are actually happening, they will obviously take up some memory in the primary memory, like we discussed earlier. So the operating system will manage this memory, and it'll do so without interrupting these processes. Like you can see that if your computer, like if you've opened Chrome, And if you open some other software, like it won't interrupt it to manage the memory. It'll just manage it in the background. That's the function of the operating system. Now, file management. Now, files in secondary memory that are saved, you would want to create them or update them, delete them, protect them, etc. The operating system is the one that takes care of all of it for us. It prevents different users from accessing other user data because, as you guys know, in a computer system, more than one user can actually have their files on it. So the operating system makes sure that one user's files are with them and no other user can actually access them, and it manages the files for them. Then our last thing is device management, which manages different devices through device drivers. We talk about what device drivers are. So OS actually controls the device drivers to manage these various devices, as in mouses, speakers, etc. So this is the end of it. Thank you guys for watching.
Yes.
If you liked it, please drop a like and comment any questions you guys have.
We'll be uploading this PPT to our website, so do check it out. It's very good revision notes for when your exams come. And besides that, it seems like a very theoretical and heavy chapter, but if you understand most of the concepts, it'll be easy. You don't have to actually memorize all the points, just memorize the main points, and it'll be much easier if you understand what actually happens. So thank you for watching. Do subscribe to the channel and make sure to hit that like button. Thank you.
Thank you.